Where do we stop the last time? I think we've covered. We've looked at bearings, different types of bearing, and we've looked at different types of compass. Okay, we've treated all of these: angle of declination, the true knots, and the magnetic knots. Okay, we've looked at designation of bearings. We've looked at reduced bearing. We've looked at how to convert old circle bearing to reduced bearing and vice versa. So we've looked at forward bearing and back bearing. All right. And I think I've explained all of this. Then the relationship between back bearing and forward bearing. There's a mathematical relationship. I've explained that too. And I've explained how to get back bearing from forward bearing and back bearing from forward bearing, vice versa. So we look at all these ones, examples, conversion. Oh, sorry, sorry. So now we've not looked at computation of angles. Computation of angles. You know, when you know the bearings between two lines, you can actually compute the included angles. And the computation of angle is quite simple. So if I give you bearing A, B, B, C, C, D, D, E, and it's a closed traverse, you should be able to compute the included angles or observed angles from those given bearings. So I won't spoon feed you on that. You should be able to do that. Okay, I think this is where I was the last time, when I was, after explaining forward bearing and back bearing, how you can get the included or observed angles. Who is that off mic? So can every one of you see this slide I'm seeing here, computation of angles? Can you see the diagram?
Yes, sir.
Good. So look at it now. We have bearing A to B. Bearing A to B is forward bearing or forward bearing. I can see the arrow. Okay. It's from, since we are dealing with compass, so our reference line is the magnetic north or the magnetic meridian. All right. So as you can see, A to B now, look at the arrow, the direction of the arrow from where it starts to where it points to, in the direction of line A B. So that is uh, uh, the forebearing A to B. And that bearing now, we can assume that bearing is more than 90 degrees. Why? Because it falls in the second quadrant. Okay, the maximum angle in the second quadrant is 180. All right, so it's this forebearing bearing AB now is more than 90 degree and it's less than 180 degree. All right, now let's look at bearing AE. Bearing AE. Now bearing AE is the back bearing. Is the back bearing. You know that if we were to move uh, uh, in the clockwise direction and we follow the normal nomenclature, let's say we have points A, B, C, D, E. Okay, so bearing AB, forward bearing, bearing BC, forward bearing, bearing CD, forward bearing, bearing DE, forward bearing, and bearing EA is also what? Forward bearing. So if I say bearing AE now, that is the backward bearing. So that's why bearing AE here is a backward bearing. All right. So now how do we get the included angle? The angle between bearing line AB and line AE, which is the angle here, as you can see the diagram. So sorry about the noise coming from the background. So how do we do that? It's very quite obvious. You know, that will be how do I get bearing angle A now? That will be the bearing of AB minus the bearing of AE. In another words, the forward bearing of AB minus the back bearing of the back bearing, which is A bearing AE. So that is what gives you angle A. And that is what is explained here mathematically expressed, as you can see. Let me zoom. I hope you can see. Oh, this usage of phone.
You can try to turn your
I
phone to
think
landscape.
what did you say?
You said you can try to like turn your phone to landscape.
Oh, okay. Okay, let's see. You've done it. The problem is, I'm in a class now. Don't let them put virus. If they put virus there, that will be another problem. You know, one of your colleagues had that experience. So we have to format, take everything out, format everything. You know, so I don't know. You take it there, ask them, no virus. If they put virus there, you will be in super. I'm trying to. How come I'm not seeing the rotation? Okay, I've seen it. All right. No, I think
I think
I shouldn't have gone too far now. I'm wondering why I couldn't find the slide we were on. Okay, so this is the slide. So I think this is well understood now. So let me move from here to another slide. So see, this is also still explaining included angles or out observed angles. So if you look at the exterior angle B, as you can see in the diagram, is equals to back bearing of AB, back bearing of AB, okay, minus forward bearing of BC. So that will give you the exterior angle of B. So where is the exterior angle of B? As you can see in the diagram, assuming they label the center now, let's see what we can do. Now, okay, let me use this forward bearing of, look at the forward bearing of BC. Look at the line M, the vertical line M. You see a small angle inside. That small angle is the forward bearing of line BC. From that vertical line M, then touching the line BC, you have the forward bearing of BC. Now, the forward bearing of the back bearing of AB, which is line BA, that same line, look at that same line, the vertical line M, which is the direction of the magnetic north now. Then, you see the angle coming, going clockwise and touching the line BA, the line BA. So that is the bearing of BA, the magnetic bearing of BA. All right. So how do I get the angle at B? The angle at B, which is the exterior angle. Let's say the center of this point, let's say is 0 now. I'm just assuming. Okay. Okay, let's take it as 0 now. So which means angle AOC. Angle AOC now is the exterior angle, which is the exterior angle of B. Are you following me now? Good. And the interior angle of B is, let me call it, let me see how I can differentiate it. Okay, so I don't think there's a letter you can use a different letter, but don't just see that the angle at the top the one at the top, touching line AB and line BC is the interior angle of B, as you can see the labeling. Then below it, we have the exterior angle B. So how do we compute all of that? It has been expressed mathematically below. Exterior angle of B, which is equals to back bearing of AB. The back bearing of AB is bearing BA. So bearing BA minus bearing BC will give you the exterior angle of B. I hope this explanation is clear to you. We are not in class where I can fully explain this for you, but I hope this is understood. Now, included angle of B is 360 minus exterior angle, because angle at a point is 360. Okay, the sum of angle at a point is 360. So if I know the exterior parts of the angle, then how do I compute the interior parts of the angle? It's just to say 360 minus the exterior angle. And it's also vice versa. If I know the interior angle, parts of the angle at a point, I can also obtain the exterior angle. So that is that. So all of this, explanation is giving you information how to obtain angles in a traverse network. Okay, so look at this. In a closed traverse, the following bearings were observed with a compass. Calculate the interior angles. So you should be able to, first of all, sketch this now, and show the traverse plots of this. Then from there, you should be able to now obtain the interior angles, the interior angles at each point of the traverse. So the same explanation goes for this bar bearing, four bearing. We've explained the relationship between those two terms. Okay, can you see now the plots, how they are calculating or computing the included or the interior angles? And don't forget, this shape you are seeing now, is a polygonal shape. Like this shape you are seeing, how many sides? 1, 2, 3, 4, 5. So this is a pentagon. Okay, so I can compute the sum of interior angles of this polygon. You know the formula. If you don't know, revert to your O-level mathematics. So you go through all of this. Can you see the computation that is also going on here? The exterior and the interior angles. So the computation of those two, the same thing here. So the same situation here. The only difference here is that they did not give you your bearing as a whole circle bearing. They gave it in form of the reduced bearing or the quadrantal bearing formats. So you should know how to move from one format to the other. I thought you said you go to the hospital. No problem. So can you see what they are doing here? The sum of exterior angles of this shape now equals to 360. Okay, this is a rectangle shape, and the sum of interior angles in a rectangle is 360. That's what they are showing you here. All right. So, and that is what they confirm after obtaining uh, the interior angles, then they sum it together and everything gives 360. So don't let me, okay, so let's go to what is called magnetic declination. I have a very low battery, but let's see how far it can take us. The horizontal angle between the magnetic meridian and true meridian is known as magnetic declination. I've told you, that magnetic meridian is the same thing as what? The magnetic north. And the true meridian is the same as what? The true north. So the angle between the two, the angle between the true, magnetic north and the true north is called the magnetic declination. So when the north end of the magnetic needle is pointed towards the west side of the true meridian, the position is termed as declination west. So when the north end of the magnetic needle is pointed towards the west side of the true meridian, the position is termed as declination west, theta W. When the north end of the needle is pointed towards the east side of the true meridian, the position uh, is termed as declination east. Okay, so take note of that. So look at the diagram explaining that explanation, explaining the statements. Now look at the true knots and look at the uh, magnetic knots. When the knot end of the magnetic knot is pointing towards the east, who is that of your mic? Points towards the magnetic. When the north end of the uh, when the north ends of the magnetic knots points towards the east side of the true knots or the true meridian, we have the declination east. When the north end of the magnetic knots points towards the west side of the true north, we have the declination west. Okay, and so this is the mathematical the magnetic bearing and the declination. So declination will not, the sign of the declination will not be uh, where the north end of the magnetic uh, needle is pointing towards. Is it the east or is it the west? So, okay, sorry. So when the, let me take this again. When the north end of the magnetic needle is pointing towards the east side of the true north, we say that declination is declination east. Okay. major time here is the magnetic needle where it is pointing. And don't forget, magnetic needle should point towards the magnetic north. Okay, so as it is pointing towards the magnetic north, if it falls in the position of the east side of the true north, then we say that declination is declination east. If it falls in the west of the true north, then we say that declination is declination west. Don't forget, what is declination? Angle between the what? The magnetic north and the true north. So look at the true bearing equals to magnetic bearing plus or minus declination. Use plus sign when declination is towards east and negative sign when the declination is towards west. So vice versa, magnetic bearing equals to true north plus or minus declination. So the same concept here, but for when you are computing for magnetic bearing now, you use plus sign when the declination is towards west and use negative sign when the declination is towards the east. So take notes of that. So look at this example now. The magnetic bearing of a line AB is 135 degree, 30 minutes. What will be the true bearing? If the declination is 5 degree, 15 minutes west, okay? So this declination now is declination west, okay? So you want to go and buy food? Eh? No. Okay. So the true bearing of a line CD is 210 degree 45 minutes. What would it be when its magnetic bearing of the inclination is 8 degree 15 minutes west? So let's quickly solve this problem. So now the true bearing of AB is equals to magnetic bearing minus declination. Don't forget, when it is declination west, it will be negative. When the object of consign or the terminology that we are consigned to compute is the true bearing. Don't forget, if it is true bearing. So true bearing will be equals to the magnetic bearing plus or minus declination. So if it is declination west now, that means it will be minus, and that's why you are having minus here, minus 5 degree 15 minutes, and the true bearing gives what? 130 degree 15 minutes. Now for magnetic bearing, now let's go back to, we are given magnetic true bearing here, which is 210 45 minutes, 210 degree 45 minutes. What would be his magnetic bearing? You know, if the declination is 8 degree 15 minutes west, so this will now be plus. That will be magnetic bearing equals to true bearing plus the declination. All right, and that is what you have here. So note those differences. So another example is true bearing of line AB is 357 degree, and its magnetic bearing is 1 degree 30 minutes. Determine the declination. So this one now we want to compute the declination. Also find the true bearing of AC, which has magnetic bearing equals to 153 degree 30 minutes. So look at it now. Magnetic declination now is 1 degree 30 minutes equals to 1 degree 30 minutes, which is I'm coming. So what we have here, the true bearing of a line AB 357 degree. So to compute the declination now, we have to take 360 from the magnetic, from the true bearing, and that is why we have 360 degree minus 357 degree. Once we do that, then we now add it to the magnetic declination. So we now add it to the true bearing. That is when we obtain our magnetic declination. But I think there should be let's go back to the diagram. Okay, so what I want to bring out from this, don't forget we are saying true bearing, magnetic bearing. True bearing is reference to the true knots. The magnetic bearing is reference to the magnetic knots. Now, in that question we look at earlier on, we were given true bearing of a line AB, which is 357 degree. Don't forget this 357 degree, which is true bearing, is reference to the true knots. Are you getting me? Now, the magnetic bearing, which is 1 degree 30 minutes, is reference to the what? The magnetic knots. Now, so, and we say magnetic declination is the angle between the true knots and the what? And the magnetic knots. So, we need to orient this to this 357. Now we need to reference it back to the true knots. So that is why we have 360 degree minus 357, and that will be 3 degree. 3 degree plus 1 degree 30 minutes will give you 4 degree 30 minutes. Now we have west here. So how it is, why is it west? Because if you sketch the diagram, you see that the declination falls towards the west side of the true knots. I don't know if do you get me? Now, if I sketch a true north direction now, and I take the true bearing, which is what? The true bearing is 357, and I sketch it. You see that the direction will fall in the direction of the what? The west side of the true north. Okay? So now to not get the direction of the true north in itself, that will be 3 degrees. Okay, so 3 degrees plus 1 degree 30 minutes. That's why we have 4 degrees 30 minutes west. Now, I hope that is clear. Then the magnetic bearing of AC is this 153 degrees 30 minutes. What is the true bearing of AC? Okay, so the true bearing of AC now will be magnetic bearing minus 4 degrees 30 minutes west. Don't forget, when it is true bearing, the declination will always be the negative, and that is what happens here. I hope this is clear.
Yes, sir.
Okay, so do I still have battery? Okay, I think I still have battery on the phone, although it has turned white. So let me quickly explain this concept and we'll call it a day. Now, what is local attraction? Whenever you are using magnetic compass, to obtain magnetic bearing, when you are doing your survey on sites, there is what we call local attraction. And local attraction occurs when there is influence of magnetic substances on site or on the field. Okay, what does this magnetic substance? What is their effects on the compass? They affect the magnetic needle of the compass. Don't forget, magnetic needle of a compass points in the direction of the what? Magnetic north or the magnetic meridian. But when there is influence of magnetic substances like iron ore, steel, etc., or electric currents, what all of these would do is to uh, make the magnetic needle deviates from the direction of the magnetic north. So when the magnetic needle deviates from the direction of the magnetic north and you use it to obtain or observe your magnetic bearing between points on the field, an error is incurred. You won't have an accurate observation of your magnetic bearing. So the concept, when the magnetic needle deviates from the direction of the magnetic north as a result of these magnetic substances, is called local attraction. All right. So, and this is what this slide is explaining here for you. So when you are on site or on the field using magnetic compass, you make sure that there are no steel, electric poles, iron ore, or any form of magnetic substances that can influence the deviation of the magnetic needle, not to point towards the direction of magnetic arcs. Okay, so that is what local attraction is all about. And you can actually detect where you have local attraction in your observation. You have local attraction when your forward bearing and backward bearing. For instance, I observe a bearing A to B using my compass. I can check if there is any local attraction in my observation by confirming if the difference between my forward bearing and backward bearing is 180 degree. If it is not 180 degree, then I have local attraction in that observation. So forward bearing minus back bearing, their difference should be 180 degree. If their difference is 180 degree, then there is no local attraction, which means the error there is 0 degree. But if they are not, it is not equals to 180 degree, then there is a local attraction. And local attraction can occur at each station, point. Take for instance, line A to B now. At point A, I may not experience local attraction, but when I'm at point B, it's possible I have local attraction, or vice versa. And sometimes local attraction can be on both stations, that is on both point A and B. It's possible, or at any of the station or points. So it is now left to you to determine where these local attraction are at each of your traverse points, okay, and see how you can detect it and eliminate those local attraction. So in the next class, I'll be showing you how to identify where local attraction in how you can identify local attraction in your observations of bearing, your magnetic bearings, and how to correct for this local attraction. Okay, so I will do that in the next class by the grace of God. We are already coming to the end of this class. Have you started your lab, your field work for this course?
No, sir.
Yeah, how are you, Khalid? So you need to get in touch with your technologists, and because you don't have time, okay? But let me mention some certain things. I want you to find out for me what we call agonic lines, isogonic lines. Then what other terminologies? These terminologies, we use them, when we are dealing with map making. So there are lines, okay? So I've mentioned agonic line, isogonic line, geographical pole. Read about geographical pole. What else? Okay, although I've explained local attraction, add local attraction to it. So it's going to be a brief write-up, and you submit to me next Tuesday. So class reps, are you here? The two class reps?
Yes, sir.
Okay, that's for geology, Abi.
Yes, good
Yes,
evening,
sir.
sir.
Geology assistant classroom.
Yeah.
Okay. Then the geophysics class rep, you are here too?
No, sir, assistant, sir.
How come the assistants are the one active? Okay, so make sure you collect those assignments for me by next week, Tuesday. I want to see those assignments. Then how many? We have 40 students here. So please, we have the attendance latest tomorrow. I don't want excuse though. If I didn't see your attendance latest tomorrow, I will record it that none of you came for this class. All right. So I don't want to hear I'm not on campus, I stay outside. I won't tolerate that excuse again. Okay. So I'm sure majority of you are in the hostel or you are squatting. Either in fact, they have legalized squatting now.
Hallelujah.
Is that not true? They've legalized it. So at least large percentage of you should have sorted your accommodation issues. So that is by the way. So we meet next class by the grace of God. This is the last class. So once I finish this topic, compass surveying, then we now go back and do revision of what I have taught for me of this course. All right. So do you have a question or we call it a day? A question?
Yes, sir.
Oh, okay. So I wish you all the best. We'll see next week, Tuesday, by God's grace. Thank you.